All right. So I'm going to talk for a little bit at the beginning to give people time. If you haven't yet cloned the repository, you need to do that. Let me show you where to go. github.com/fractaledmind /Euruko-2024. So this is the repository that we will be working with. Hopefully, more than half of you have already cloned this repository, so we're not slamming the conference Wi-Fi at the same time right now. But for those of you who haven't, go ahead and do that now. So let me tell you a little bit about the structure of what we're going to be doing. Everything that we are going to be doing lives in this workshop directory. So, first key point, this is a self-guided workshop. Strictly speaking, I am utterly unnecessary for today's proceedings. However, I really like the sound of my own voice, so I will talk from time to time. And I am here to answer any questions you might have. Those can be questions about what we are doing, and I'm going to be going through the workshop along with you all. They can also be tangential questions. That's totally fine. So, second key point. First key point, clone the repository. Second key point, at any point that you want to ask me anything, just put your hand in the air, and I'll come see what your question is, and then we'll talk about it. It does not exclusively have to be a question about the steps and process of the workshop. Anything that comes into your mind you want to learn more about, understand better, feel free. This is intended to be a very easy to follow, free-flowing workshop. That's why everything is in Markdown documents. Every step that we're going to be taking is fully there. So it's easy to take tangents, talk about concepts that are introduced, tools that are introduced, anything that we need, and then we can get back on track super easily. Because it is a self-guided workshop, that also means you are free to ignore me for however long you want, at whatever point you want. You can just follow the Markdown documents as you go and speed race the workshop. You could probably do it in 30 or 40 minutes if the Wi-Fi were really good. In this case, it might be a bit slower, we'll see. And that's totally fine. If you, at any point, get to the end, or you get to the point where you're satisfied with what you've learned in your experience, feel free to leave. It's not, no, I won't be offended. There's no obligation for you to sit here for the next 2 hours. And you can also get a sense, oh, this is a public repository that is a self-guided workshop. I might just do it later, and I really want to go see these other talks. Also, totally fine. No harm to my ego at all. So, those are the key elements of how this is going to go today. Now, a little bit more introduction to give you a little bit more time as you're cloning the repository and starting to skim this first document, which I'll start getting into myself here shortly. So, I want to be honest with everyone here. We are going to be doing a lot of very specific things. We're going to run a number of commands in the terminal. We're going to be installing gems. We're going to be setting them up. We're going to be making changes to configuration files. There's all kinds of minute details. To be upfront with you, in about 2 weeks, give or take, who can say exactly, around 75% of these manual steps will be pointless for you to know because they will be a part of the Rails new command. And that's really exciting. So when Rails 8 is released, a lot of this is going to be handled automatically for you. And we've been working for a long time to make that the case. It isn't presently the case. You run Rails new today, you don't pass the -- main flag, and you're going to have to do all 12 of these steps, and there's various things inside of them. Woo! Hecklers. Ugh. So I want them all to be in there, and I want us to go through them, but the primary purpose of this workshop is not to learn each of these minute details. That's why I just wrote them all down, and they're just there, and anyone can go and read them. The primary purpose of this workshop, and this goes back to, please raise your hand, ask questions, I want to have a conversation, because the primary purpose of this workshop is for you to come out of it feeling comfortable and confident that you know why Rails 8 does all of these things, why we are doing all of these things. How does Ruby and SQLite and Rails layer on top of each other, work together? Where are the edge cases? Where are the rough edges? Why are we smoothing them out in these ways? So that when you start a Rails new application in a month from now, and 80% of this stuff is just given to you out of the box, you have an understanding of what this application is doing, why it is configured in this way, why it is valuable or useful to start a new application going all in on SQLite as your persistent data store, but without requiring you to take an hour and manually change all of the files that you need. So we're going to be working in a Rails 7.2.1 application. We're going to be manually going through all of the steps that are needed to get that application production ready in the way that I define production ready. We'll get more into that. And in a few weeks, you won't have to do 75% of it. I think that's a win. I still think this is a valuable workshop, but it's going to be much more valuable if we dig into the concepts. If we make sure that we all understand, why are we doing these things? Why are these tools here? So again, please ask questions. And if you're not asking questions, ignore me and follow the self-guided workshop. Okay? There we go. All right. Does everyone have the repository cloned? Yes. All right. So I'm going to head up to my seat and switch mics, and we're going to start walking through this. You hear me now? Yeah. Okay. I want to start by just showing you the basic application that we're working with, so that we aren't lost and confused on this. It's a super simple application. The business logic here is meant to be boring. I'm not trying to do anything interesting or fancy here. This is a really simplified Hacker News-like clone. I call it lorem news because all the text is lorem ipsum. We have posts. So the root route of the application shows you the most recent 50 posts. Posts are posted by users. They have a title and content. If you are the user that submitted that post, you can edit it or destroy it. Anyone else can post a comment. Anonymous users can read all of the content of the website, but only authenticated users can write new posts or add new comments. If you are the author of a comment, you have the ability to edit it or to destroy it. if it is edited, it's tagged that it is edited. This is making a new post. There it is, super simple. If at any point you find yourself looking into the models or controllers, you will see they're very boring and very basic, just getting this simple authorization logic around anonymous users and signed-in users. So, how do we start? We want to understand what is the conditions of our application out of the box. And I want to start with understanding the performance characteristics that we're working with. So the application comes with this benchmarking controller. This is a simple little controller that I put together to make it easy for us to run very basic heuristic load tests that we are not super meaningful to the real world, but they're meaningful relative to each other. So we can see improvements over time, but I'm not trying to suggest that these are production realistic load tests. Better now? I can go more. So we just have a number of standard CRUD actions that this application might do, right? We can create a post, create a comment, destroy a post, destroy a comment, show a post, show the post index view, or show a particular user. For all of these actions, we sign in a random user. This is one key detail. We're going to talk about it more as we get into it, but it's important to remember that even though we think of HTTP requests, right? A GET request is a read request and a POST request is a write request. In almost all production applications, even GET requests are going to be doing database writes, right? So I want to make sure that we're always doing database writes, at least one. So that's why we have this before action. Just find some random user and start a session for them. This benchmarking controller allows us to use a simple load testing CLI. I use a tool called OHA, which is in the instructions. If you have it, you can use it. If you haven't already downloaded it, you can try to download it. I don't really know what the state of the conference Wi-Fi is, but you don't have to. For this performance section, if you want to just save the bandwidth, all of the content is written down. I'll run over some of it. There is one, but it doesn't work. Live demos. Yep. Yeah. So to echo that for everyone, copy the master.key file, config master.key, to config/credential/production.key. Yeah. Svatoslav is suggesting that this man is a hacker. He's not a hacker. He's just smarter than Svatoslav, so it's intimidating. Yeah. Master keys are like the bane of my workshop existence. And I tried really hard to get it right this time, and I made an improvement from the last time I did a version of this workshop, but I still haven't quite perfected putting these applications up on GitHub in such a way that you pull them down and they immediately work. But yeah. So this man is also not a hacker. He's just smarter than me. But that's a good point. You can also change the bin serve script to export the Rails master key. You can just like cat it out and put it in the environment variable. That's also smart. And I'll make that change to the repository for the people who do this self-guided. So this load testing tool, if you have it, if you want to use it, if you want to play with this yourself, allows us to get a baseline of where our application is at before we make any changes. And in general, I find it useful to get a baseline for the read-heavy requests and the write-heavy requests. So I'm going to use post-index as my sort of sentinel for read-heavy requests. And I'll use, I think, post-create as my sentinel for the write-heavy requests. So I really wish that I knew how to configure the color of its output, but I don't. But you can see example results in the document. The key stuff is here. Let me put this here so it's at least high contrast. We see what I would describe as bad performance. We are running this load test with 20 concurrent requests over the span of 10 seconds. This is to ensure that we're sending more concurrent load than the amount of like Puma workers we have set up. I'm doing this right now against development. You'll see in the instructions you should set it up. Use bin serve. It'll use the production environment, which will spin up Puma in a more performant way. You can set the number of workers to match the number of cores on your machine, which is 10 on my case. But looking at the details, so this is like a more standard example from running this on my machine against the bin serve command. You'll see that things look pretty okay. We have everything go through, everything works smoothly. This has improved over time, right? We've been incrementally shipping fixes to Rails that somewhat randomly. It's hard for me to predict which point releases or patch releases are going to get which ones, but as of Rails 7.2.1, we have a handful of performance fixes. There are two major ones that we're going to get into that are only going to be in Rails 8, that we're going to explore what they are here and how to make them work and what Rails will be doing. But I ran this workshop 4 months ago, and I talk a little bit about the difference. It's a like 5x improvement just from Rails, whatever that was, 7.2.0, I think, to Rails 7.2.1. And if you want to read more on like the details of what's been changing in Rails, there's This Week in Rails blog posts, and I've written about them on my blog as well. If you run the post-create load test as well, you're going to see some noticeably different results. I'm just taking some time here I'm saving myself some time to not run it all myself right now. I will be running some of this stuff as we go, but I just want to sort of set the baseline more quickly. The key detail that you're going to see if you run this yourself, like you are going to see this, is that we have a ton of errors. And this is like the major problem. And this is why I make this point at every conference I go to. I want everyone to like hear this super clearly. If you run Rails new today, so you're using the default database, which is SQLite, you build out your application logic, and you put it on a DigitalOcean server, you use Hatchbox, what have you, you put it in production, you are going to cry. You're going to feel great pain. It is going to be a bad experience. And you're going to get on Twitter and you're going to write, this asshole Steven told me SQLite was the cool new shit, and I put it in production, and like 70% of my requests are erroring out. This is terrible. I always knew you should never use SQLite in production. Okay, that's true. Don't use SQLite in production without understanding how to use it correctly. And the really important point is that in a couple of weeks, Rails will solve all of these problems for you. But let's understand what the problem is and how Rails solves it so that we have a better appreciation of where the pain points lie in using a database like SQLite in a language like Ruby with a framework like Rails. So, step 2, improving performance. The simplest thing that you can do is make sure you are using the most recent version of Ruby. I intentionally set this workshop up to start the application using Ruby 3.1.x. You can walk through the document here in improving performance where we focus on Ruby. I incrementally bumped it from 3.1 to 3.2 and from 3.2 to 3.3. I'm not going to take the chance that some of the gems that I downloaded a week ago have new versions and I have to pull them down from Wi-Fi right now. So I'm not going to bump them now. I'm just going to talk through the results from when I wrote all of this down a week ago. Each major version of, not major, the 3.x version of Ruby has had noticeable performance improvements. And specifically, Ruby 3.3, for reasons I confess I do not fully understand. I think it has something to do with Widget and maybe other things, but it makes the experience of Ruby and SQLite working together much better. You will see the number of error responses. Let's come down to the right. Post create. So this is just 3.2. Our error responses ratio is shrinking. It's still not great though, right? This is a lot more errors than successes. When we come to Ruby 3.3, I'm going to skip the read here and jump straight down to the right. Or is this one just the read? I'm just scanning this. The key point is that our errors start naturally resolving. Ruby 3.3 does a much better job with managing the connections under concurrent load. So key takeaway number 1, in general for really any Rails app, but specifically for SQLite on Rails apps, you should absolutely use the most recent Ruby version. There are real noticeable improvements version over version, and it's the cheapest win you're going to get until we get to Rails 8, and that's like the cheapest set of wins because we really have done everything for you. So get to Ruby 3.3. But let's talk about the core problems that we are noticing. Like, what's happening here? Why do we have these errors? The first problem is how SQLite and Ruby work together in a concurrent environment. If you run those tests and you look at your logs, what you're going to see for all of those 500 responses is this error. The statement invalid active record exception, which is wrapping the SQLite 3 busy exception because our database is locked, right? So a really important concept and sort of architectural limitation that we all need to understand about SQLite is that it only allows linear writes. So this means you can have one write operation, and then once it's done, another write operation, and once it's done, another write operation, but you can't have two write operations happening concurrently. And this is different from MySQL or Postgres. MySQL or Postgres have capabilities to do fine-grained concurrency control. So one write operation can say, hey, I'm only going to be working with this row. So if another write operation needs to work with this row, it needs to wait on me. But any write operation that's working on another table or on another row in this table is fine, and they can happen in parallel. SQLite, the level of granularity that you have is the database. So if one write operation is occurring, everyone has to wait. And if you don't tweak how you use SQLite, this is what you're going to experience. You're going to have 10 Puma workers. In my case, 10. I have 10 cores, so I set up 10 Puma workers. I am sending 20 concurrent requests, so they all need to be processing things. And at various points, 2 of those workers are going to be processing requests that need to do database writes at around the same time. And one of them will get in, and the other one won't. And it'll throw up its hands and error. Obviously, this is entirely problematic. Like, you can't put an application in production with this kind of behavior. Digging into what is actually going on, I'm going to save you days and weeks of research and troubleshooting. My first thought was, I'm very confused by this because I know that SQLite has a mechanism built in to queue those writes. So naturally, operation 1 comes in, operation 2 comes in, 1 wins, 2 just waits until 1 is done, and then it runs. It doesn't throw an error. It will increase the latency of that operation, but it's fine. So, like, why are we seeing hundreds and hundreds and hundreds of errors? Well, because SQLite has this limitation, it has a unique behavior with transactions. So if you go and read the docs on MySQL or Postgres, for any of you who are like a little bit more knowledgeable about those databases, you will see that they both have some additional keywords that you can pass to the begin transaction statement. There's knobs that you can tweak, change the behavior. This is common of databases. SQLite has its own knobs. It only has 2 knobs, so it's quite simple. You can start what is called a deferred transaction, or you can start what's called an immediate transaction. And the default behavior, if you just execute the SQL string begin transaction, that will be a deferred transaction. And what that means is SQLite will defer trying to acquire the write lock until a write operation is triggered inside of that transaction. So if you were to, for example, begin transaction, select star from posts, select star from comments, commit, it will never try to acquire the write lock. That will just be a read operation, and you could have 1,000 of those happening at the exact same time, and that would be fine. But if you had begin transaction, select star from posts, insert into posts, values, blah, 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 and then select star from comments. Those are 4 SQL operations, right? Begin transaction, select star, insert, select star. Only on that 3rd operation would SQLite say, oh, I'm doing a write, let me try to grab the write lock. And if when it tried inside of that transaction, some other connection from some other Puma worker was currently writing and it had that lock, Because we're inside of a transaction, SQLite says, well, I can't queue this up because when I run it again, I could get a different database snapshot. And you presume that you're going to be working with the same snapshot because we've already done the begin transaction, which is where we take the snapshot of the database state, and we don't want to have these bizarre behaviors. So in that case, and only that case, SQLite immediately errors. There's no way to queue those things up. So the solution is that in Rails applications, because we know we're going to be using a connection pool, we know we're going to be spinning up multiple Puma workers, we know we're going to be working in a concurrent environment, it is essential that our application begin immediate transactions. Because what an immediate transaction does is it tells SQLite, when you execute the operation begin immediate transaction, SQLite attempts to acquire the write lock right then. And if the lock is already held, that operation is safe to queue because that's the operation that acquires the snapshot. So it's going to take a snapshot and acquire the write lock in the same operation. And so until it's able to acquire the write lock, it's not taking a snapshot, and your state is always going to be consistent. So that's the problem, and that's the solution. Let's talk about how to make sure that your Rails application is doing that. It's luckily very easy because the lower level gem that we have in Ruby for controlling SQLite from our Ruby code allows us to specify a default transaction mode. And so at the very bottom of what's happening here, this gem is generating a string that it is sending to SQLite's C code, which it then parses and runs the operation on. And so it can either generate the string begin transaction, or the string begin deferred transaction, or the string begin immediate transaction. And you just pass the default transaction mode. And little known feature, perhaps, I don't know 100% if this is true with Postgres and MySQL because I haven't read that part of Rails super closely. But in the active record adapter for SQLite, it is certainly true. Any key that you set in your database YAML is forwarded to the initializer of the SQLite gem. So if you look at the signature for SQLite 3 : database, any option that is available in the options hash there, you can specify in your database YAML, and it automatically is wired up. So if we simply specify we want our default transaction mode to be immediate in our database YAML, our problems will be solved. So this problem, the solution is genuinely as simple as this. One line in one file. We're going to put it in our default block so that it's true for all of our environments, right? We want this to be true of every SQLite database in every environment that is executing. You can observe this for yourself, rerun the load tests, and you will see that indeed the errors will disappear. It is a incredibly high leverage fix. And you might now have an appreciation for the fact that this is exactly the kind of thing that the framework should do for you. There's no need for every single Rails developer who is scaffolding a new Rails application and wanting to use SQLite to have this be the case. It has actually taken a while to get this into Rails because, well, there's a whole bunch of reasons. I won't bore you with them now unless you specifically ask about them, but it is done, and it will be true in Rails 8, but now you have a much deeper appreciation of why this change was made. It's a very low-level change that you're not going to see it in your database YAML. It's handled at like the lower levels of how active record talks to the SQLite gem. But this is the kind of thing that we are going to be facing. Like, you really have to understand, how does SQLite work? What kind of environment are we going to be using it in? What are the constraints of those environments? And then how can we make them work well together? But this is the first major problem solved. I want to take a breath, and I'm going to explicitly ask, does anyone want to dig into any particular part of this before I move on to the second problem and the second solution? Works worse with? Yeah. So, yes. So here's the core problem that we faced getting this into Rails. When you make this change in your database YAML, this is an application level change, not a framework level change. And so when I made the pull request, and I basically just put this line in the initializer inside of active record, I'm like, it'll be fine. I've been running this in my app. Everything is totally fine. What could be the problem? Well, the way that fixtures are managed in Rails, they use database transactions. So it'll start a transaction, shove in all of your fixtures, run your tests, and then roll back that transaction. That's how database state is managed inside of tests when using fixtures, and all of that is in Rails code. That particular use case of transactions is dependent on using a deferred transaction. Like 30 plus, I don't even know, a bunch of Rails tests started failing when I made this change, and it took me a while to figure out what the hell was going on. So that's one example. There are legitimate use cases where you might want a deferred transaction, and hard coding immediate transactions, then without any escape hatch, prevents you from, for example, using a transaction as a sort of wrapper around state that you want to just roll back after you do an operation. So we had to do a lot of work to figure out the interface to expose to applications to allow them to specify a different type of transaction in active record. Aside from that, the trade-off that you're going to make is you're going to have some increased latency, but you're not going to have errors, right? So previously, these things were running pretty fast because they would just error immediately. And now you are going to have some queuing, and that's the second problem that we're going to talk about. So it's a natural sort of transition. You could imagine, let's go in the back though. To the secret, to the master key? My helpful assistant will help you out. So, yes, that would be another example of where the Rails framework itself needs to definitely be able to use both kinds of transactions. In general, though, it is the case that at the app for your application, you definitely want to use immediate transactions. So that's why that is now the default, and then you have to manually tell active record, this transaction I want to be deferred. And you'll see the API for that in the release notes for Rails 8. We can, I think, pretty naturally, though, imagine what the follow-on problem is. So we have now removed the errors, but SQLite only supports linear writes, and they queue up. And so you could imagine, let's say, I've got 10 Puma workers. I send them a write request all at the exact same time. They're going to queue up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th one will have to wait for the other 9 to finish before it runs. And that Puma worker responding to that web request won't be able to respond until that database write is done. So that particular request will be the slowest out of that batch of 10, right? That'll be like your P90. And how slow could it get? Well, by default in Rails 7.2.1, it can be way too slow. So I created these little ASCII diagrams to walk through the problem. So this is with 4 instead of 10, right? But you have this queue of database operations, and they're just going to wait until one by one the other ones run. And when you go into those load tests, you're going to see like your P99 will be over 5 seconds, which I think is fair to say is also untenable for production. In trying to figure out what was going on there, this is another case. I'm just going to save you for my case, you're probably smarter than me, but for my case, it took me about 2 weeks to understand what was going on. But I did have a clue, because that 5 seconds is suspiciously similar to this timeout. And that eventually led me to understand what was going on. So I want to walk through this problem. And this is the second major feature of Rails 8 for resolving problems with SQLite. So I'm going to explain it with words. I also explain it with text, and then we can talk about it afterwards. If you are used to using Postgres in MySQL and you have ever tried to debug or read posts about performance of your Rails application, then you are already familiar with how important it is, given that Ruby has a global VM lock, to differentiate between Ruby execution and not Ruby execution. And when you have 10 Puma workers, the way that you have good performance is that you ensure that while one Puma worker is doing Ruby work, as many of the other Puma workers are able to do as much non-Ruby work as possible. And there's been a lot of work done in the Ruby community over the last 3 decades to make that just work. But the core detail that's happening there is that there's a distinguishing that occurs between Ruby I/O and external I/O. Right? So if you're using Postgres and you make a request to your Postgres server and it's on another machine or it's on another process, the Ruby driver that is talking to Postgres and allowing you to write Ruby to talk to it knows how to tell the Ruby interpreter, hey, I am no longer doing Ruby work. Postgres is doing Postgres work. You can hand the GVL to another thread, to another Puma worker, and when I get the response from Postgres, I'll let you know, and I'll wait in line to get the GVL back. And so you have true concurrency, right? So only one Puma worker at a time is doing Ruby work, right? In this way, Ruby is very similar to SQLite. It has a linear execution of Ruby work because of the GVL. But you can be doing all kinds of other work. You can be talking to Postgres, you can be talking to Redis, you can be talking to the file system, you can be, there's all kinds of different I/O. But Ruby needs to understand when your application process is busy doing Ruby work and when it's waiting on external I/O. Well, one of the great advantages of SQLite and what makes it so fast is that it is an embedded database. It's not a separate process. It's not something that you run on another machine. It's not another process that you add to your proc file. It is embedded inside of your application process. It's embedded, in fact, inside of the threads. So if you spin up multiple threads, you're going to have multiple different connections, and each of them is running the SQLite executable, which is just a bundle of C code. And because it is an embedded database, Ruby does not naturally know when you are waiting for a SQLite query that's sitting in the queue. By default, to Ruby's interpreter, that looks like Ruby work is waiting, and so it holds the GVL. So your application process is sitting there, not doing anything. No Ruby is being executed. We're just waiting on SQLite to resolve the queue and to execute that write operation. But the whole time, that particular Puma worker is holding the GVL, and so no other Ruby processing can be going on. Right? You can't have another Puma worker that's starting to parse the actual plain text of the HTTP request, or running through the Rails router, or starting to execute your controller. All of these things that could be going on to massively increase your throughput and decrease your latency. So the trick, the thing we have to figure out how to do is how to tell Ruby, that the Ruby interpreter, that we are waiting on external I/O, right? It's embedded internal I/O, but from the point of view of Ruby, it's external I/O, such that it releases the GVL and allows other Puma workers to get their job done. So there's some details here about SQLite's implementation. The key detail, though, is that we need to define our own busy timeout, is the language that SQLite uses. This is just the queuing algorithm. And SQLite exposes a API to allow you to define your own. The SQLite 3 gem exposes a Ruby interface for that C interface. And if you use Ruby's sleep, Ruby knows, oh, I'm sleeping. Like, I will release the GVL and I'll let other Ruby take control. So this here is a Ruby re-implementation of SQLite's busy timeout implementation. This does exactly the same thing as SQLite C code, but it's written in Ruby, which means that this sleep command is a Ruby sleep command, which means that the GVL is released every time we do an iteration to wait to see if we can acquire the write lock. And that will massively improve your application's long tail latency. But it doesn't improve it as much as we need. And so there's a second part to this problem, which is that for reasons I haven't archaeologically discovered yet, I hope to remember to write a post in the forum and have someone tell me. Whenever they implemented this, right, they set up this backoff. And the result here of this like growing backoff is that if you have a query or an operation that tries once, waits a millisecond, still not able to acquire the write lock, tries again, and then it's not able to, it waits 2 seconds. After two milliseconds, not seconds. Tries again, still not able to, waits 5 milliseconds. It's at this point. It tries at this moment, and it still isn't able to acquire the write lock. It's going to sleep for 10 milliseconds. While this operation is waiting to even try again, if you have any other write operations that hit SQLite, they are starting here. They're going to have 3 opportunities to acquire the write lock before that first operation even checks again. And so if you have heavy, just consistent write load on your database, you are going to have operations that get pushed to the very end of the queue. And so they're going to have incredibly low latency. They're just going to always wait, because each time they wait, their odds of having to wait again go up. And so you're always going to have one unlucky query. If you have consistent enough load over enough time, this is another reason why I run the load test for 10 seconds. The timeout is 5 seconds. You will have one query that times out in the kind of load test that we've set up. So you're going to have a P99.99 that goes 5+ seconds. So it isn't sufficient in our case to use a backoff. we're going to presume that we're going to have consistent write load, and we're also going to presume that we have fast processors. And so we're going to implement a consistent sleep. Every write operation, every time it checks, is going to wait 1 millisecond. So there is no statistical penalty to trying 5 times versus 1 time. You're just as likely to resolve. This is the implementation that is now in the SQLite 3 gem. And this solves our long tail latency problem. So whether it's P99 or P99.99, you don't see this graph, you see a flat line, which is what we want. Again, all of this is going to be true in Rails 8. This is really nice, like everything comes out of the box correct for you. But I want the people who care enough to come to a workshop like this to have a deeper understanding of what's going on. Before I turn to how you would make this true in a Rails application, like what hackery you need to do to switch out these implementations, I'm going to pause again for questions around this problem space and the nature of this solution. I think he's confused. Okay, I'll push forward. So this is unfortunately more complicated than the previous one. This one is actually easier to, this pull request was easier to do at the Rails level than it is to do at the application level, which was the inverse of the previous problem and solution. We're going to need to actually patch. We're going to need to monkey patch some Rails. So let me just give you a really quick speech on monkey patching. Don't do it unless you have to, and if you have to, do it and feel no guilt, but do it well. And let me show you a little bit about what I think it looks like to do monkey patching well. Point number 1, write a lot of comments. Really clearly explain the conditions that have led you to reaching into the guts of a framework and swizzling things around. Number 2, be super defensive, right? Really explicitly encode your expectations about the code that is existing that you're monkey patching. You don't want to get into these weird states where, like you upgrade versions and the actual code is slightly different, so you're not actually monkey patching it, you're just adding new functionality, and things get weird. So, and then the third point is like, try to define some deadline at which, like programmatically, you either no-op the monkey patch, or you tell yourself, you send an error to Sentry or whatever to say, hey, come back and check our conditions. Like, do we still need to keep this? You want to remind yourself to get to a place where you remove this. So we have this monkey patch. We're going to make sure that we, like, does the constant even exist that we're trying to monkey patch? Right? Very defensive programming. Does the method even exist that we want to monkey patch? Does the method have the arity that we expect? Right? Has its signature changed? Because if it has, like, we should error and go back and change this code. And what I am doing here is I'm mapping one method to another method. Right? So there's a, coming back up here. This code lives in the SQLite 3 gem as of now. And on Rails 7.2.1, if you just run Rails new, you're going to get a version of this gem that's past this. So this code lives there. What isn't the case is that Rails doesn't use it yet in 7.2.1. So we're basically redirecting one attribute writer to no-op and instead call another attribute writer. So I want to do that same thing. I want to check that that other method that I want to call instead exists. I want to check that its arity is what I expect. Right? I've encoded my expectations, and then I just make the patch. So this method, instead of doing what it normally does, instead calls this other attribute writer. There's more stuff in the text about like what's going on here, but basically this method directly calls the SQLite 3 set a busy timeout, which is going to hold the GVL and create all the problems from the beginning. This is the setter that tells SQLite to instead run this code. So all of that's in the gem, so like our patch can be quite lean and straightforward. And we apply that patch. So if you put this in an initializer, it's going to run at the appropriate place in the boot process, right? We want it to be early enough that it applies everywhere, but late enough that all of the stuff we're monkey patching already exists. Initializers are the perfect spot for monkey patches. Again, don't do them unless you have to, in which case do them, but do them well. You can check that everything is set up correctly. This is something I try to have in every step here of the self-guided workshop, right? To say like, here's a quick sanity check for you to run to make sure that things are actually doing what we expect them to do. So you can jump into a console and you can check the source location of this method, and it should point to your initializer file. And if it does, all right, monkey patch is set. If you rerun those load tests, you're going to see the same results. I have some pretty graphs when I do this in slide version, but I can just do it with my hands. Before, after. Very good. You can follow the sort of results here. The key thing that you're going to see, right? This 99.99th percentile response time at 600 plus milliseconds. Before we did this fix, that was like 5.3 seconds. Right? So we improved it about 1,000 times, which pretty good. If you are actually building a Rails 7 1.2 application and you don't want to, or you can't use Rails 8 when it comes out, or use Rails main today, and you want these fixes, you have two options available to you. You can do these things. You can make these changes in your application as I have described them. They will do what you need them to do. And there are some programmers who prefer that kind of solution. I want to see the code in my repository. I want there to be a git commit that has a git diff that is understandable about what has changed and why. And that's totally valid, and that's why I wanted to like walk through what's really going on. There are other programmers who are like, this kind of stuff should be solved for me. I don't want to have to think about it. I shouldn't have to think about it. And there's a solution for you as well. You can simply add the enhanced adapter gem. So its proper name is Active Record Enhanced SQLite 3 Adapter. I'm not always great with poetic gem names, but you know what it does. You know, it does what it says on the tin. This gem it has a rail tie that automatically applies these patches to your application. In addition to a few other things, so there are a number of fixes and feature additions that have been made to the SQLite 3 adapter in Rails over the last year, and they have been released in various versions of Rails. So this gem also makes, like, it backports them. So if there's a feature that was added to Rails 7.2.0 and you're on Rails 7.1.2, the gem will backport that feature and make it available to you. So one example of that would be virtual columns. It is possible in Rails 7.2.1 to, using the standard Rails migrations, to define a virtual column that, a virtual column, a generated column, the language is slightly different, but it's the same thing, right? It's a column that is defined on the database, but its state is computed from some function. That can be a purely computed state, or you can actually have it stored on disk, right? So this is like the difference between a materialized and a non-materialized view. That's a feature that's in Active Record, that's in Active Record 7.2.1. It's not in Active Record 7.1. You might want it. So this gem does performance patch fixes. It also backports some of these features, or all of these features that are there. Or you can wait till Rails 8, or you can use Rails main, and all of these things are obviously in Rails main. This is a pick your flavor kind of situation. If you are using a Rails 7x application, you will have these problems. You must have these fixes. Here's what the fixes are. Here's what they do. Here's the different ways you can apply them. But that is the end of the performance section. And from here forward, we're going to talk about features. So I'm going to take another pause for any conversation that we want to have around performance, SQLite on Rails application performance. Yeah. Let's wait 1 second, because I heard magnitude of impact and then they started clapping and I didn't hear any of the rest of it. Yeah. We can bring you the mic.
We're running it on max, so that it has to be there, and the do magnitude, we're running a small how much is important that we put it in SD?
So, in part one to my answer, I haven't done like a thorough study, but I think it's today probably harder to rent a machine that doesn't have an SSD than one that has a spinning disk. But the difference between spinning disk and SSD for SQLite is going to be the same as the difference between a spinning disk and an SSD for really any other kind of file I/O. So like SSDs are going to be much faster and much better. In terms of like, can you get away with using a spinning disk or like using an SSD that isn't like NVMe? Absolutely. It really depends on the requirements of your application. So just to give you an example from a production application I've been running for a few years, it is a B2B application for like 5 specific customers, which are companies, and they all have multiple users, but like the total number of users in the database, which include employees in our company and employees in their companies. So like the users table does not have more than 200 rows, right? And it is a standard CRUD style Rails application, right? It's not doing other kinds of fancy kinds of I/O, right? It's a web UI to a database. That has been running on the second price tier of DigitalOcean for 3 years, no problems. Now, that is an SSD. I don't even know how to get a spinning disk on DigitalOcean. But when you make these patches where you're actually unlocking SQLite speed in the environment of concurrent connections that you're going to be working with in a Rails application, you can serve relatively large, I mean, like large enough to be making real money. That application is a very enterprisey application, so it makes like millions of dollars in revenue with very few people using it on very small machines. In general, just to re-emphasize like the scale of this last fix for your tail latency, like for your very slowest requests, this last fix, is on the order of magnitude of 1,000 times in improvement for your slowest queries. For your fastest queries, there's really no difference, right? Those are the ones that win immediately. I want the right lock, I get the right lock, and I run and I'm done. So when you apply these patches, it really opens up SQLite speed, and on SQLite speed, you can build like actual applications that can make you actual money on relatively tiny boxes, including spinning disks if you have one in your basement that you want to hook up to the internet and use. Did that answer your question? Okay, we're going to turn to features next. I'm going to give you the outline of this section in advance. There are, let me count them on my hand as I go. 1, 2, 3, 4, 5. 5 key features that we're going to talk about. The first is data resilience, right? And it's first because it's the most important. Don't delay setting up data resilience. I say this as someone who delayed setting up data resilience and then accidentally deleted his production database and spent a day trying to recover it from the Linux memory dump, which didn't work, and then had to figure out how to reset the business without pissing off all of these customers, which we were able to do, right? So it worked out, but it was a very important reminder. Data resilience, set it up on day 0. Run Rails new, then do this stuff. Just do it immediately. Save yourself the heartache. Second feature is going to be a part of a section, which is unlocking all of Rails's features that require persistent data with just SQLite. How do we get background jobs? How do we get a cache store? How do we get WebSockets? How do we do error monitoring? Can we do all of these things without requiring to connect to other machines, to connect to managed services, to spin up other kinds of services? Yes, we can. How do we do that? And then, so there's 3 of those. So that's 4. And the 5th feature is how can we start to take advantage of SQLite's unique architecture to do interesting and fancier things with our application? So those are the set of features we're going to talk about. And we're going to start with data resilience. So I'm not going to spend any time on the sales pitch for why you should care about this. You should care about this. Your database is just a file on disk on the same machine. And you definitely want to be able to have that machine die, but your business not die. Right? That's kind of mission critical. So set it up on day 0. I have spent a fair bit of time trying to make it as easy as possible to get as resilient and robust a backup strategy in place for SQLite applications. And I'm going to walk you through what all of the tools are that we provide. Luckily, all of these things live in a single gem. It is called Litestream. Litestream is a Ruby gem that packages a utility, an open source utility, called Litestream. This is a single Go executable that does one thing and only one thing, and it does it very well. And it is finished software. It's beautiful. What it does is it runs as a separate process, and it watches your SQLite database. And anytime your SQLite database changes, it takes that change and it streams it to some bucket storage service that you have configured to send it to. All right, so Amazon S3 is the canonical example, and there are now many services that use that same protocol. So you could use DigitalOcean Spaces, you could use Google Cloud Platform buckets, you could use Backblaze R2. Hell, you can even set up your own FTP server and it'll send it over there. But that's all it does. It's going to stream each change that is written to your database to a bucket. And then on any other machine, it can be the same machine that it's backing up from. It can be your laptop. It can be a new machine that you're spinning up because your previous machine died. Once you get that executable installed, you can just run restore, and it'll replay all of those changes. It does some smarter things. It's not just like exclusively a stream of changes. It takes snapshots and aggregates them every now and again so that the restore command is fast. But the key detail is that it is simple, right? The operational complexity to set it up is very little. You just need that Go executable, and we've packaged it up into this Ruby gem. So bundle add Litestream will get you the correct executable for your architecture, installed everything for you. It gives you point-in-time backups, right? Every single atomic change to your application that is made is streamed. And they're all like time-stamped, so you can restore relative to a point in time. You can say, you know, I want my database as it was at 3:14 p.m. Give that to me, please. And it is cheap because bucket storage is cheap storage. And it is smart about how it saves the data into the bucket storage. It's not like bloated. So you can have backups for pennies. So that's why I recommend it. There are other alternatives. There are other utilities. There's also SQLite itself has a backup command you can run. It'll do a clone of your database file, and you could set up a cron job and just run that and take those files and put them wherever the hell you want. Like, you know, so you could have at whatever interval you want, you could do that. There's all kinds of options. I recommend Litestream. That's what we're going to talk about because I think getting point-in-time backups is worth it. And we have brought the operational complexity to a level where it's not a high cost to get the extra benefit. So how do we get it? We just add the gem and we run the installer. 2 steps and you're done. The installer is going to add 2 files to your project. It's important that we understand these 2 files. So the first one is the configuration file that the Litestream Go executable is using, right? So config Litestream YAML is configuring the utility itself. You will see the way it is created. It will scan your database YAML, find any SQLite databases that are defined in your production environment, and make sure that it tells Litestream to back up all of them. This is going to be useful because, as you will see shortly, we're going to use separate databases for every persistent data component that Rails has. So we're going to have a different database for solid queue in our background jobs, and a different database for solid cache in our cache backend, and a different database for solid cable in our WebSockets, and a different database for active record in our models. So, and then we're going to set up error monitoring as just a little spice at the end, and we have a different database for error. So we're going to have 5 databases, and we want to have them all backed up. It's also going to use environment variables for your credentials. So you're going to have to tell it, here's my bucket storage service that I want you to use, and here are the credentials to access it. In order to make it as easy as possible for you to manage those credentials, we also create a Ruby initializer. And the gem provides a Ruby configuration layer to allow you to set those credentials in Ruby. This file is all commented out, but the example that it puts in there is the example of storing those credentials in Rails credentials. And this is how I would recommend doing it. It's like the simplest, most cohesive way. Everything lives in your repository, everything's in source control. And it allows you to put your credentials that are going to drive Litestream in the same place you put all of your other credentials for your application, and to make sure that they are correctly piped into the utility such that everything just works. So that's why we have two different files, and that's what they're doing. For this workshop, just to help you to actually see what's going on, I also recommend that you just set up and run a min.io instance. Min.io is an open source bucket storage service that implements the S3 protocol. And it also has a Ruby gem that provides precompiled binaries. So easy to download. You spin it up and are then able to use that as the place that you're going to send your backups. And so you can actually watch everything that's happening. You can go in and look at each of the snapshots and generations, or what Litestream calls it. I'm just sort of attentive to the time, and I'm just not going to run all of these. I have run all of them, which I wrote this just by doing all of this stuff and copying all of the commands and all of the output. So it should work. If it doesn't, open an issue on GitHub and we'll get it resolved. But I'm just trying to move a bit faster. So you can follow the workshop and you will be able to run everything and see everything going on. So this is what it looks like in the initializer, right? We can pull out our Litestream credentials, pass them into the configuration. I really tried to lay out every single detail, right? So you can just copy and paste all of these things to get it to work. The gem provides rake tasks so that you can ensure that you are running the different commands that the utility provides with the Ruby configuration layer applied on top first. So if you're using the gem, you should use the rake tasks because they make sure that the Ruby and the Go know how to talk to each other. So there's this env command, which you can use, or rake task, to make sure that your environment variables are being set correctly. You know? So once you have everything set up in your Litestream config, you can just start the replication process. So this is going to spin up the Litestream process that's going to sit and watch your database and stream the changes. It logs everything so you can see what's going on. And if you are setting your Rails app up in such a way that you are going to need a proc file, or you just prefer managing separate processes, this is how you do it. This is how you start the replication process. You add this to your proc file or whatever thing you're using to manage your different processes that are needed for your application. But in the desire to make the simplest possible path as simple as possible and available, the gem also comes with a Puma plugin. So you can build your application without any need for a proc file, without any need for process management. You can just go into your config Puma RB file and add this plugin. And Puma will manage that process for you. It'll spin it up when the Puma process starts. It'll spin it down if the Puma process is killed. And everything just works. TM. So this is, again, like my recommendation for you're just starting something, right? You're bootstrapping something, or you're building a demo, or you're doing an experiment at work. I would start as lean as possible. And the Puma plugin, very lean, very straightforward. Don't have to manage all the processes yourself. Let Puma handle that. So that's all that it takes to get your database backed up. Bundle add Litestream, bin Rails generate Litestream install, put the credentials in your credentials file, put the plugin in your Puma config, and your databases will be backed up. Now, obviously there is the second half of this equation. You're backing up your database. How do you restore? And not just how do you restore, even more importantly, how do you ensure that this backup system is working? Because you don't want to find out when you actually have deleted your database and you go to restore a backup, oh shit, 3 weeks ago, this whole process stopped working and actually I'm screwed. So we're going to talk about how to restore from a backup, but even more importantly, we're going to talk about how to ensure that this backup process is staying healthy. So restoring from a backup, you use the rake task, Litestream restore. And you have to tell the rake task which specific database to restore. Because you can, in the configuration, be backing up multiple databases. And you're going to be in a Rails application probably that does. But even if you only have one, you still have to tell the restore command the name of the one to restore. You can optionally give it an output path, tell it where you want to restore to. The details here of this rake task signature are important. If you have ever written rake tasks, you have faced this problem, I expect. How the hell do we pass arguments to rake tasks? Why is this so goddamn annoying? You can find all kinds of stuff on the internet about how to do it. There's various suggestions. I personally think that the simplest way to do it is to just use argument forwarding. So you do rake task, space, dash dash, space, and then you pass some arguments. And those 2 dash dashes there are essential for things to work. So I want to call that out. So if you ever need to restore a database, there you go. Very straightforward. You need to have the Litestream utility on that machine. In this case, we're going to use it inside of a Rails application and have bundle added it. So we're going to use the rake task. So we have all the configuration there. This is what it's going to look like when it is doing things. Download the wall, apply the wall, rename the database. You can see the logs. You can verify, right? Like, is this a real database? Can I open it? Like, so run the SQLite 3 REPL. This will confirm, yes, you can open it. It's a valid SQLite 3 database. You can then like check the data. Data is there. It looks like the data that was in the other file. Restoring databases is pretty easy. Verifying backups is where we want to spend some time. So the gem is not just a download wrapper for precompiled binaries, right? It gives you this configuration layer, and it also gives you these tools to verify your backup process. The foundation of the tools are this class method, Litestream.verify bang. What this method does is it ensures that there is an underscore Litestream verifications table in your database. So create table if not exists. It will then generate a UUID, and add that row to that table. It will then sleep for 10 seconds. After 10 seconds, it will run the restore command to a particular file location, timestamped. It will then use SQLite to open that restored file and attempt to read back that row with that UUID. If it reads back that row, it returns true. Otherwise, it raises an error. I want to walk through all of the things that this verifies for us. So, firstly, it verifies that your database is streaming updates to the bucket at least in 10-second windows, so with no more latency than 10 seconds. 2, it verifies that the Litestream gem can restore a database from your bucket service. 3, it verifies that the file that is written from the restore command is a valid SQLite database that can be opened and understood by SQLite. And then 4, it verifies that that file actually has that fresh data that was just put in 10 seconds ago. This is, I think, a pretty rock-solid verification process. But you do have to run it to see. And if you forget to run it for a month, and inside that month you lose your database, it might not be that helpful. So the other thing that the gem provides is a background job that iterates over all of your databases and verifies them. And so if you have a background job backend that supports setting up recurring jobs, you can just point it at this job at whatever interval you want. What I do is I run it every day at 1 a.m. You can do whatever you would like. Now, if you want a background job backend that provides recurring jobs out of the box and also requires no other operational dependencies, have I got a pitch for you? So this is my transition point, but I will pause after that really beautiful and elegant transition to see if there's anything that we want to talk about when it comes to Litestream and database backups. Yeah. Yeah, so just to repeat so everyone can hear, he was asking just to double check. If you're using this approach, you're only using one server. You can't have a load balancer that is coordinating between two servers, and so if one goes down, we send all the traffic to the one that's still up, and we spin up another one, and we have high availability, right? So the answer is mostly yes, but not forcibly so. So my recommendation is you should vertically scale a single server when using SQLite on Rails applications. And my belief is that at least 70% of the actual web applications that actually are running on the internet, that is all that they need. It is also my belief that at least 70% of all of the web applications that people think are worth writing about on the internet are not those. So there is this inverse where the only thing we read about are the ones where it's like, well, obviously I need to have a node on every continent, and obviously I need multi-master replication. I mean, come on, do you think I'm an animal? But for example, the applications that I was building at my work, they were not the primary monolith. That primary monolith is a crowd service application. So we really do need nodes all over the globe because we have 100,000 users literally all over the globe, and it's important for our business that we have low latency everywhere. So that main monolith is a distributed application and uses more complicated database architectures to manage that. But when we build a application for a particular enterprise client that has a particular need and has a set of business users that are there, and all of our administrative users are here, and it's possible for me to keep latency at 500 milliseconds maximum with one server that sits here and costs me €8 a month. I don't use all of the Kubernetes and Helm charts, and I don't need all of it. So that's point one. I highly recommend that you really consider, do I truly need it? 2 points. If you start there and you become a millionaire and you have the next base camp and you have 400,000 users and you're making a ton of money and you're like, I really need to beef this stuff up. Point one, actually, you can probably run that on one box because these boxes are huge. You can rent huge boxes. But if you reach the point where you really need to go multi-node, it is possible with SQLite. There are tools that are there. There is a successor to the Litestream utility called LiteFS, which does node-to-node replication. And so you can set up multi-node settings. This was acquired by Fly.io. So this is now technology that's baked into the Fly.io multi-region deployment infrastructure as a service kind of setup. So you can go that route. There are other tools. There's SQLite and other things. The one caveat that I will make is that definitionally, those tools are less battle-tested than other tools for other databases, right? So VTest for MySQL, right? YouTube built that as YouTube scaled to the moon. That has been serving massive workloads for many massive companies for decades. There is not a single company in existence that has used LiteFS at that scale for that long. LiteFS has only existed for 2 years. So if you get to that point, you might make a decision like, I'm going to change databases and sort of change the whole architecture. You're not required to. There are tools that allow you to horizontally scale with SQLite. And there are also some other approaches. There's a really good blog post. I think the internet's probably good enough to pull this up. Oso Kafka SQLite. This is a really interesting blog post. This is a company, Oso, that does authorization as a service. And they talk about how their customers are going to be making API requests to them for all of their web requests. So it's essential that their latency is super low. So they are distributed, regionally distributed. But they also need their latency to be really, really low. So they don't want to have a centralized database and eat all of that latency. So they have a SQLite database sitting alongside all of their regional deployments. But then how do we keep those SQLite databases in sync? They use Kafka and a custom setup of Kafka as the replication engine to keep all of those things in sync. It's a really thorough blog post that lays out their architecture quite well. One of the key details that they make, right, is that like they are in an environment that is a standard Pareto distribution. 80% of the requests that come to them are reads and 20% are writes. So it's totally fine for them to have a bit of replication lag because they can very much control that use case in that situation, and it's only going to apply to like the 99.99 latency, and they have managed it to get it down to like below 500 milliseconds, but it allows their standard latency to be below 10 milliseconds. So there are like other things you could like roll your own. So that's like a full-winded answer. I would really recommend don't horizontally scale until like you actually have to like exhaust your possibilities, because the operational simplicity that I think drives the value proposition for building SQLite on Rails applications is really shines in single node deployments. Now, the final thing to say to this is that we can do things. This is not important. Let me just come back here. We can do things to mitigate our time to manual recovery, right? So we could have a cold standby. So we can just have a server that we're renting, and so we don't have to eat the cost of spinning it up. We could also have a warm standby. So we could set up our CI service to deploy our application to both machines. So our application is already there. We could have a hot standby by setting up whatever you want, a cron job, a systemd service, whatever, on whatever interval you want to pull down database backups. So that so like when you have a warm standby, the only time to recovery is how long will it take to pull down the database backup. If you're pulling the database backup every hour, like you can bring that down some. All of these things, like you're going to have to make sure to coordinate the timing of when your primary application goes down. You don't want to bring this one up while this one's still up and you lose rights. But there are layers of operational complexity you could add to keep your time to recovery low in a window that is reasonable for you. But just as a reminder, 3 nines of uptime is 40 minutes of downtime a month. And you can spin up a DigitalOcean machine that just needs Docker and deploy with Kamal and something in 2 minutes. Just to get us on like the same order of magnitude of like the time we're talking about. It is not difficult if you plan for it and know what you're doing to build a service with 3 nines of uptime, even on a single box. Could you get screwed? You could get screwed, but at that point you're screwed. You know, what are you going to do? Okay, let's talk a little bit about fleshing out the feature set of our application. So I presume that you're with me. You see the value proposition, like operational simplicity and speed and power, but in a lightweight sort of box. But we want, and we probably need, the full range of features that Rails offers us. Well, and this section will also be not needed with Rails 8 because solid queue and solid cache will be the default adapters in Rails 8. And SQLite is already the default database, so if you just run Rails new in a month from now, you're going to get SQLite backed solid queue, SQLite backed solid cache. Your primary database will be SQLite. But if you want to see what the Rails generators are doing and what they're setting up, we can walk through it. Solid queue, for those of you who don't know, is a new gem that is under the Rails GitHub namespace, originally created by the team at Basecamp. That is a database-backed, but database-agnostic job backend. So it's similar to Good Job in that it is a database-backed job backend, but it's not Postgres only. You can use it with MySQL, which is what Basecamp uses it with. You could use it with Postgres, or you could use it with SQLite, or you could use it with Oracle, or whatever you want. This will be the new default in Rails 8. It is a really great gem. I've been using it in production for a while. I'm a fan of it. And we'll get to the part where it's quite nice because it offers recurring jobs out of the box. That is a part of its feature set, which makes it incredibly easy to set up our backup verification job to run for us every night. One key detail. So we've been here for a bit. We're coming to the end. Want to make sure that we capture this. Strong recommendation. For each persistent data component, use a separate database. SQLite only allows linear writes per database. So you want some concurrency? Spin up 3 databases. Boom, boom, boom. Hell, you can get parallelism. No problems here. And we have been solving the problem, like we talk about in background jobs, this is like a whole other set of talks I do on resilient background jobs, and it's like when you have two different I/O backends, how do you make sure that they are coordinated with each other? When you can't just wrap something in a database transaction? Sure, okay, that is a problem. That is like a very well explored problem space. Rails is adding features to make that even easier. So like Rails 8, I think it hasn't come out in Rails 2.1, right? But the automatic in-queue jobs after transactions, right? So they brought the after commit everywhere gem into Rails, and then they even made it such that when you're in active job and you in-queue another job inside of a transaction, Rails will just automatically say, this is stupid, we're not gonna do this, we're gonna in-queue it after this transaction commits. Like, so you really should just separate the databases. It ensures that you can have heavy web requests and heavy job activity without either of them being degraded from the fact that both are heavy. So how do you set that up? Just like you can use YAML aliases to define like a block, a named block, like default, you can set up like your queue database. You want it to be a different database with a different migrations path, different name, and then you need to point your different environments to it. You're using Rails as multiple database support now, so this is like the transition from 2-tier config to 3-tier config. Right? So right now we're in 2-tier config, tier 1, tier 2. So the only database of our application is the primary database, so we don't specify the primary key here. As soon as you have multiple databases, you have 3 tiers, 1, 2, 3. You can read more about multiple database support. You can run the installer. It's going to give you a configuration, give you the schema, prepare the database against the schema. You want to tell active job to use solid queue. You want to tell solid queue to use our separate database. All of these things are in the Rails, like this is what Rails new is. Everything you see here is what Rails new does in Rails 8. So you can do this today and you're going to be very well positioned to upgrade. It'll be a very easy upgrade. If you want to run the job process, there's a new bin stub to spin that up for you. It also ships with a Puma plugin. So if you want to start lean and simple, you don't have to have multiple processes. You can put everything managed through Puma. As you start to grow, you can split it out. You're like, actually, I do want to like have more explicit control over the processes. You can get a proc file. You have your bin job. You have your Litestream replicate. You have your Rails server. It comes with scheduled jobs. So in your config file, there's a dispatcher section. This is where we want to go. That's a list of objects. Inside of there, you have recurring tasks, right? So we just want to add our recurring task. You might have guessed I like very long descriptive names, right? So I call it the periodic Litestream backup verification job. I bet you know what it does when you read it. And you can just point it at the job that's in the gem and schedule it however often you want. So I'm hoping to add a generator command that will do this for you to the gem later. So you still have to do this manually, but there'll be a generator command there. So when you start a solid queue, you will see it. There's another gem, you can get a web UI, right? So we've all probably grown accustomed to Sidekick web dashboard. Web dashboards are useful for background jobs. You can get one for solid queue, mission control jobs. This is another gem that lives under Rails. This is a part of the new Rails stack. This will come with Rails 8. It's an engine that you mount. Background jobs. You can do them today. This is what Rails 8 will do for you. Solid queue is very nice. It's particularly nice when you want to use SQLite. Back everything that you need right there. Solid cache, same thing, but for your active support cache backend. We're going to set up another database file. We're going to put it into our environment. I'm going to run the installer. We're going to get some configuration. We're going to prepare the database. If you want to use it in development mode, use it in development mode. Make sure that you tell it to use our separate database. Again, all of this stuff is like the Rails 8 generator. This is stock standard stuff. And then you can just use the cache. It's saving records to the database, pulling them out. One thing to note as we're like approaching here the end of time, I built the workshop in this order around like priorities. If you actually like want to build an actual application and like put it in production tomorrow, do these steps first and Litestream afterwards, because the Litestream generator, as I said, will automatically introspect your database YAML file and back up every database that's in your database YAML file. So if you run it after you've installed these gems, it will correctly make sure that you're backing up your primary database, your queue database, your cache database, etc. So I put it first because I really wanted to emphasize, like, don't forget to do this. Do it before you put it in production. But in reality, it's better to run that installer later. You don't even have to worry about it when Rails 8 comes out because Rails New gives you these things. One small note, I don't have in this workshop solid cable. I pulled it out because a week ago, when I was finalizing this and writing all of these docs, they moved the milestone for solid cable to Rails 8.1. And so there was an alpha gem, but it was being maintained by someone who's not in the Rails core team. The GitHub repository was not under the Rails GitHub organization. And I thought, okay, I'll hold off on this for a moment. In that week since, they have said, yeah, everything looks good. They moved the repository under the Rails namespace. They are going to release it as a part of Rails 8. The process to set it up is exactly the same. You're going to have a cable database. You're going to run the installer from the gem. You'll see all of that on the README. The key point here is that those are the three major persistent data components of Rails. And you can back all of them with SQLite. They all will work. So you can get a full-featured application. There's no feature of Rails that is withheld from you if you want to only use SQLite as your sole operational dependency. So it's not in here, but it should be in here. But the instructions are basically the exact same. Bundle, add the gem, run the installer, add the database. There are other gems. I just want to flag this. I'm like speed running here at the very end. I want to open your eyes to the possibilities here. Rails engines that you mount, that have views, that show you data that is useful to you. So we're going to think about the Sidekick web UI. You can throw a little SQLite database, pipe whatever data you want in there, build whatever web UI is useful to you. This is like a really powerful pattern. I've been exploring it in a few different ways. So the first one that I did, so it's the one that's production ready, solid errors, error monitoring. Rails comes with error subscription built in, right? You don't have to do much fancy stuff. So we can build an error subscriber that's just going to pipe errors into a SQLite database. We can build an engine that has a simple view that shows you all of the errors sorted by most recently occurred. You can click on them, view all the details. It's like the simple version of Honeybadger, but it's free. And so if you're bootstrapping a new project and you're like, I don't have a lot of capital, don't give up on error monitoring. You should have error monitoring 100%. Start off free. You get some users, you get a little bit of MRR. You're like, okay, now I could use some real features, upgrade to Honeybadger, right? But you can have it on day one. What are other things I'm working on right now? It's not production ready, but Rails has instrumentation. We could pipe instrumentation into a SQLite database, build a simple view. You want to know, what are the queries I should pay attention to? It's not simply what are the ones that take the longest. It's not simply what are the ones that are run the most. It's which are the ones that run the most and are taking the longest as a sort of log multiplier of those two factors. And I want to see the SQL, and I want to see like all the details of its execution or anything else, controller action, any of the instrumentation of Rails. I was talking with Tim, who spoke here yesterday. He's doing the same thing with structured logs. You don't need to use the paper trail service on day 0. Use a structured logging gem. Structured logging will be coming with Rails 8. This will be even easier. Pipe it, map the JSON into relational columns in a table, build a web view. You can see all of your logs. Like, once you open your eyes to these possibilities, like, yeah, there's a whole suite of data from my application, about my application that I want, that would be useful to me. This is an incredibly powerful and easy pattern. These little engines like Solid Errors has like literally 4 views and like 3 tables, two tables, and come up with more great ideas. Like, let's grow this ecosystem so that the day 0 experience of bootstrapping applications can be feature rich and set ourselves up for success as we grow. And as we grow, we can like grow into more powerful but also more expensive things. That's totally fine. That's totally like natural. But we can start with rich, powerful applications that aren't difficult to maintain and also aren't expensive. I'm now out of time. The other things you can do here are really cool. You should check them out. Your database is just a file. You want to do branch-specific databases? You can bind Git branches and databases such that you never have inter-team conflicts of migrations. It's super easy. Did you know you can do ERB in your database YAML file? Well, if you didn't, now you know. So you can just say, I want my database name to be my Git branch name. And then just tell Rails in development, after initialize, run prepare on my database so that it makes sure the file exists and the migrations are run and everything's there. If you want to be able to move data around, that's not that hard. Here's a bunch of bash scripts. You can study them, but it's like move all of the data from this database file to this database file. You could also just like say, I want to create a new database file from this one with the same schema and the data. You could take all of that, hook it up to a Git hook, so you could ignore the Rails stuff, just do it directly through Git. This stuff like becomes possible and easy. Bundler manages the compilation of SQLite for you, so you can actually control the compilation flags. So if you really want to fine-tune the usage of SQLite, so you get to a point where actually this 5% performance improvement would be really valuable to me, it's easily available. Bundle config set, build SQLite, go study the SQLite compilation flags, pick the ones that are useful. If you want like a 3% performance improvement and you don't mind tweaking the compilation, here's the recommended set of compilation flags. This will give you somewhere in the range of like 1 to 3% performance improvement over the standard use case. It removes some features that you might want, but you have full control there. SQLite comes with a lot of extensions. You can install those extensions. You can use them. There's an unofficial package manager for SQLite extensions. It's another Go executable. We can wrap it up in a precompiled binary gem. It's easy to add to your project. You can use it to install those gems. The gem that wraps it up makes it easy to use inside of Rails applications. It has over 100 extensions for SQLite. So you can use extensions for location data. You can get high-level math functions. There's all kinds of stuff. Of course, AI is the talk of the town. There is a extension for vector search built into added onto SQLite through the extension that is available there as well. Making sure those extensions are loaded into the connections that Active Record is using is easy. The gem provides those patches and things for you. So that's like a speed run on all of those. All of the details are in the workshop. Here at the end, I hope, I've just been yapping at you for 2 hours, but I do hope that at least some of you feel comfortable and confident that you could go out tomorrow and start a new application, put it on a box on DigitalOcean or Hetzner or wherever, and make your best stab at trying to make some money in this world. And I really do genuinely think that, especially for this sort of like vision of bootstrapping, right? Like Rails is a one-person framework, empowering you as an individual to like try something to see if there's some market for something. SQLite really offers you unique leverage. It is powerful, but it is simple. The operational overhead is so minimal. It takes a little bit of change in your thinking from what we're used to with Heroku and like that style of Rails application architecture. But hopefully you've started to wrap your head around what it takes, where the pain points are, where the rough edges are. But these things can be smoothed over. We have smoothed over all of the ones that we are aware of in Rails. And you can build full-featured, powerful, valuable applications. You can run them incredibly cheaply. And you would be surprised at how many users, how much revenue is available to you with this level of simplicity and control. So thanks for hanging out with me for a few hours. Happy to chat with you more over the afternoon. Thank you.